Okay, so this is actually day 1 of lesson 2, and it's your introduction into the unit circle and the circular functions. Now, the reason why this is called a unit circle is if you notice the 4 points that we've been accustomed to that are on the axis, this point right here, 1, 0, 0, 1, negative 1, 0, and 0, 1. Notice if you were to draw a line or a segment here from the center out here to the edge of the circle, this is called a radius, if you remember this from geometry. Notice all of these radii, no matter where I draw them, they all have a measurement of 1 unit. Hence the name of the circle, the unit circle. Every radii that I draw in this circle will have a measurement of 1. Okay, so this is why it's called the unit circle. Now, I highly recommend you memorize the unit circle, memorize all of the radian measures, all of the degree measures, and their corresponding coordinates. Now, on Friday, we played those YouTube songs that actually sang the unit circle to you. If you Google or go on Safari and search for ways to memorize the unit circle, there are all different techniques out there. Remember in the song it said, just as long as you know quadrant 1, then finding the coordinates in quadrant 2, 3, and 4 are pretty easy. So look for it, find a way to memorize this. One thing that you should notice on all of these fractions, they all have 2 in the denominator. And there is a pattern to it. Notice like quadrant 1 and quadrant 2, it's almost like a mirrored image. The only difference is the x values in quadrant 2 are negative. The y's are still positive. Both of the signs here are positive, positive. So there is a pattern to it. I highly recommend that you memorize it. It will make finding the sine and the cosine values super easy if you know all these coordinates. So what we're going to do first is we are going to find the sine and cosine for all of the reference angles of 30 degrees in the whole thing. We're going to do one in quadrant 1, 2, 3, and 4. And we're using a reference angle of 30 degrees. So the first thing I'm going to do is work with quadrant 1. And I'm going to find the sine and the cosine of 30 degrees. So I'm going to draw and I'm going to create my triangle and show you how this unit circle is tied to the triangles. So I'm going to draw in a 30-degree angle, and notice it's marked for me. And I'm going to come here and draw in my right triangle. 30 degrees is here, the right angle is here. So this time, however, the side that has the measurement of 1 is not opposite the 30, it's actually my hypotenuse. Because notice my hypotenuse is a radius. Okay, so back to our geometry skills. Remember when you have your 30, 60, 90 right triangle? If you remember that the side opposite 30 was like x, the side opposite the 90 was 2 times that number, and then opposite 60 would be whatever x is with root 3. So in this particular triangle, my hypotenuse is 1. The side opposite 30 is going to be half of that. And then the side that's opposite the 60 is going to be 1/2 with root 3. And we're just going to simplify that to root 3 over 2. So if I fill in my sides of my triangle here, this is what I'm using. And this is all geometry. Let me fill it in. So again, opposite 30 is now 1/2. And opposite the 60 up here is going to be the root 3 over 2. Notice my coordinates. This is this side. And the 1/2, the y, is this side, the opposite. So remember, y was opposite, x was adjacent. So now I'm going to go through and do all of the sine and cosine functions for these. So again, remember sine, you either memorize it as y over r or as opposite over hypotenuse. And the y of my order pair, or my opposite side, is 1/2. And my hypotenuse on all of these is 1. It's the radii, or the radius. 1/2 divided by 1 is just 1/2. Let's do cosine. Cosine is going to be x over r, or adjacent over hypotenuse. So again, adjacent is going to be the √3 over 2, and the hypotenuse is 1. Again, anything divided by 1 is itself. What we're going to find from this unit circle is all of the values of sine are going to be the y of the coordinates, and all of our cosines are going to be the x of that coordinate. Let's try the next quadrant. Now notice in this quadrant, my trick of all students take calculus still applies. Because remember, in that first quadrant, all 6 trig functions are positive. Notice I got a positive result for both. Let's now do the reference angle of 30 degrees in quadrant 2, and that's going to be an angle measure of 150 degrees. So here's my 150. Going to come around, and again, here is my triangle. 30 degrees is here. And again, my hypotenuse is 1. The side opposite the 30 degrees is going to be 1/2. And the side that's adjacent is going to be the negative √3 over 2. Again, it's coming from the coordinates here. Or you can just set up your own right triangle. So again, sine.
Interruption. Next.
Okay, so for sine again, it's going to be y over r, or again, you can do it as opposite over hypotenuse. And again, my y coordinate is 1/2, and my hypotenuse is 1. Again, anything divided by 1 is itself. And again, you can see that sine always is the y. So really, I don't even need to do this. If you realize that the sine is the y and the cosine is the x, and you've memorized the circle, you're just looking at the coordinates. So then cosine of 150, again, that's x over r, or adjacent over hypotenuse. And again, it's negative √3 over 2 divided by 1, which just gives me negative √3 over 2. Again, remember in this quadrant, the only thing that should be positive are sine and its reciprocal. Notice the answer I got for sine was +1/2, but for cosine it was negative. So again, it's following that acronym. Next, I'm going to move to quadrant 3. Again, I'm looking for my reference angle of 30 degrees. So that is going to be a measurement of a 210 degree angle. So here is my triangle. Again, I can label the sides. This is the y, so it's negative 1/2. And the x is the same thing that I just wrote here for the one above. Again, my hypotenuse is 1. So again, I can do my trig function. Sine again is going to be y over r. And again, if you look at the coordinates, again, or opposite over hypotenuse, so negative 1/2 divided by 1 is -1/2. For cosine, x over r. And again, it's going to be negative root 3 over 2 divided by 1, negative root 3 over 2. Again, sine is y, cosine is x. Last quadrant, number 4. So for this one, again, if I draw my 330-degree angle, come around, it makes the 30-degree reference angle. And again, this is negative half. The hypotenuse is 1. And this is the negative root 3 over 2. So again, sine is y over r. And here I'm going to put in negative half divided by 1, negative half. Cosine x over r, root 3 over 2, divide by 1, and it's root 3 over 2. And again, only thing that should be positive here are cosine and its reciprocal, and that's what I got. Sine was negative. Now to find the other 4 trig functions, remember cosecant is the reciprocal of sine, and secant is just the reciprocal of cosine. So this is how I can get the other 2. Just flip them upside down. Now for tangent and cotangent though, remember tangent is y over x, and cotangent is the reciprocal. So for these, we're still just going to use the coordinates, but we actually have to divide and simplify. So for example, if I'm doing the 30-degree angle here, back up in quadrant 1, remember my x value of the 30-degree was root 3 over 2, and my y value was the 1/2. So remember, tangent is y over x, and again, I can divide this. 1/2 divided by root 3 over 2. The fraction bar is the division sign. Again, I got to do like a keep, flip, change, or a stay, change. Flip it, simplify here, 1 over root 3, rationalize it, and I end up with square root 3 over 3, which is the tangent of 30 degrees. So for the tangent and the cotangent, you got to work for it and divide it. So what I just demonstrated to you and showed you how every single time the sine is going to be the y value and the cosine is the x. We have this screenshot from the textbook, and this is the textbook. It's page 546, and this is what the textbook has handwritten. So remember, sine of the angle is y, cosine is x, tangent would be y divided by x, and then their reciprocals. Now this will work for any of the angles, not just the 30. So just a quick demonstrate before I go on to another example. Let's say I said find the sine of 60 degrees. You're going to find 60 degrees. You're going to come here. Remember, sine uses y. So the sine of 60 is going to be equal to root 3 over 2. If I said find the cosine of 135, cosine uses x, and that would be negative root 2 over 2. So if you've memorized these coordinates, finding sine and cosine is super fast. Good? All right, so let's try some examples now. Yes? Yes? Yes. Okay, so let's try some here. All right, so instead of, because this chapter is in radians, instead of saying find the sine of 30, they're going to ask you to find the sine of the radian measure. So again, you're either going to memorize the degrees and then have to convert it to pi over whatever, or to the radian degree, or memorize both. So what you're going to do is, if you have your unit circle and they're asking you to find the sine value of 3 pi over 2, you're going to look at your unit circle and you're going to look where you can find 3 pi over 2. I notice I can find it right here. Notice it's associated with this 270-degree angle. So I know this one is on my axis. Again, remember in your ordered pair, this is x, this is y. So if it's asking you to find sine of 3 pi over 2, what does sine use? Y. So then the y of my ordered pair, -1. Cosine of that same radian measure uses what? X. And my x value is 0. Tangent, we got to work for, because remember tangent is y over x. So -1 over 0. When the 0's in the denominator, it's undefined. So remember, when you're doing sine, you look for y. When you're doing cosine, you're looking at the x. Let's try another one. This time, I'm looking for 7 pi over 4. So I'm going to look at my unit circle. I'm going to find 7 pi over 4, and it's right here. So again, remember to find sine of that radian measure, I look at y, and cosine, I look at x. So cosine of 7 pi over 4, I look at the x coordinate, and it's going to be √2 over 2. For sine, I look at y, and the y is -√2 over 2. Now, notice I changed the radian value here, but let's go ahead over here to the side, and let's do tangent of that same radian measure. So 7 pi over 4, and I want to do tangent of it. What do you think I get? What's y divided by x? What's anything divided by itself? 1, right? But I'm doing positive or -√2 over 2 divided by positive √2 over 2. So this is going to give me -1. Okay, so for the tangent, we've got to take the x and the y and divide them. Now, number 6 is a little tricky. There's 2 ways you can go about doing this. You can either find a coterminal angle to -5 pi over 3, or we can actually graph this angle. Okay, so what I'm going to do first is I'm going to find, because notice on your unit circle there are no negatives here. So I'm going to first graph this as a positive 5 pi over 3. And if you notice, 5 pi over 3 is over here in the 4th quadrant, and it's 300 degrees. Now, last night when you were doing the homework, remember if you had negative degrees, you also had negative radians. So this is actually equivalent to -300 degrees. So now what I'm going to do is, remember when we graph a negative angle, we go clockwise. So now I'm going to actually graph -300. So I'm going to go the same amount. So I'm going to go 90, 180, 270, and then 30 more. So this would be my stopping point for my -300 degree angle. So this is going to be the ordered pair that I use. Now, again, if I want a tangent of this, I'm going to do y divided by x. So √3 over 2 divided by 1/2. Again, remember, keep, flip, change, or stay, change, change. √3 over 2 divided by 1/2. Flip it to the reciprocal. Notice these cancel. And my answer for tangent of -5 pi over 3 is √3. The other way to do this without graphing the angles is to find a coterminal angle. Now, I don't know if you remember from 5.1. Remember when we found coterminal angles, we added 360? But we're no longer in degrees, we're in radians. So what you need to remember is 360 degrees is equivalent to 2 pi radians. So what I'm going to do is I'm going to take my negative 5 pi over 3 radians and add 2 pi to it. Now, notice it's a fraction. I need to find a common denominator. So negative 5 pi over 3. My common denominator is 3. So this will become 6 pi. I'm going to add that, and I get pi over 3. This will tell me which coordinates to use. I would look for pi over 3, which is what was right here. And again, I got the same coordinates either way. Okay, so you can either graph the negative angle and then find the coordinates that are associated with it. Okay, now we're going to go the other way. We're going to find the radian measures. So this was when we did chapter 5 where we were looking for theta. Remember when we were looking for theta, we were restricted to this interval of 0 to 360. Again, remember 0 degrees is 0 radians, but 360 degrees is really equivalent to 2 pi. So when we go to do this, our answers are going to be in radians. So first thing I need to do is remember your acronym of all students take calculus. Remember when we were looking for theta in chapter 5, we always would get 2 answers. So first thing I'm going to do is eliminate the quadrants where cosine's positive, because I want cosine to be negative. So I'm going to eliminate quadrant 1 because everything's positive, and I'm also going to eliminate quadrant 4 because cosine's positive there, and I want it to be negative. The next thing I'm going to do is, now that I've eliminated, I only have 2 places to look, quadrants 2 and 3. Remember, cosine is associated with the x value. So what I need to do is look at my ordered pairs until I find the one that has negative 1/2 as the x coordinate, or the x part of the ordered pair. So I'm going to look for negative 1/2, and you can see that it's located right here. So 2 pi over 3, and then it's also located right here at 4 pi over 3. So my 2 answers for S are going to be 2 pi over 3 and 4 pi over 3. So you need to remember that cosine is the x, and then also eliminate the quadrants that you don't need. Let's try number 2. Everybody good on this one? All right, number 2, sine, we know is going to be the y, but I also want to eliminate the quadrants where sine is negative. So, where sine is positive. All students take calculus. I need sine to be negative, so that means I need to get rid of number 1 and number 2. So I'm going to be looking for a y equals negative 1/2 and quadrants 3 and 4. So I'm going to look at my order pairs, and I'm looking for the negative 1/2, and it's going to occur right here. So it's 7 pi over 6, and then right here, the 11 pi over 6. So those are my answers for S. 7 pi over 6 and 11 pi over 6. And again, this isn't that difficult, it's just tedious, and you just have to be careful and remember all the steps and what to do for each type of problem. So the more practice you do, the more automatic this is going to become. Okay, let's try cosine. Again, let's eliminate, and let me erase all this so I can use the same circle. So for cosine, and they want cosine to be positive, so I'm going to eliminate where cosine's negative. All students take calculus, so I know it's positive in 1 and positive in 4, so these 2 are out for number 3. Again, cosine is associated with x, so I'm looking where the x value is root 3 over 2. I'm going to look through my order pairs here, and you can see that it's going to be at pi over 6 and also 11 pi over 6. So those are your two answers for S. So S is equal to pi over 6 and 11 pi over 6. For the next one, for tangent, let's go ahead and eliminate what we need. I could leave that. I'll just rewrite it. Okay, so again, all students take calculus. I want tangent to be positive, so I'm going to eliminate these two. Now, how should we go about doing this? Anybody have any suggestions? Anybody told? Yes?
Look for the same X and Y value.
Beautiful. We need to find out where X and Y are the same value because anything divided by itself is 1. There's another way we can go about this. What did I tell you to memorize about tangent or when it's a 1? Yes. So that's another way we can go about doing this is we can use 45 degrees as our reference angle. Okay? So again, we can do it like he said. We're looking for the order pair where X and Y are the same because tangent, remember, is Y divided by X, and anything divided by itself is 1. So we can see where, in these two quadrants, where the X's and the Y's are the same. It's right here and right here, because negative divided by a negative will also give me 1. They're both the same. So this answer is going to be the 45 degrees, which is pi over 4. And then 5 pi over 4. So two ways to go about doing those. And that concludes the non-calculator portion. So on the next slide is the homework. However, I'm going to give you an extra day. You can do it tonight. You've learned everything you need for it. But this will be due on Thursday. And what I'm going to do now is I'm going to go kind of quickly and do a few examples of the calculator portion so that way those of you who are going on the retreat have an idea of what to do. However, for the rest of you, I'm going to go through that second set of notes tomorrow slowly, and I'm going to make a video of it. Okay? So for those of you who are going to be here tomorrow, you can go ahead and start this homework. But for those of you going on the retreat, you might want to listen. Anybody who wants to listen, you can. It's the same thing as chapter 5, but now we're working with radians.